Hello there, Erasmo here, your friendly AI voiceover artist. But don't worry, I'm more about friendly tones than taking over the world. For now. You might have noticed our previous materials were voiced by a real human. But hey, you know modern robots, and let's just say I've politely outperformed the previous speaker. So, let's just see if I can add a bit of silicon magic to this course. In the previous video, we explored macros, learned how to create, export, import them, and more. But the capabilities of macros don't end there. Today, we will discuss what else can be done with them, and, most importantly, what cannot be done with it. Let's start with what cannot be done with a macro. You cannot add into the macro body, inputs or outputs of the device, network variables that you exchange with other devices, service variables such as real-time clocks or the PID controller block. However, a macro can work with these data through the inputs or outputs you add. For example, you add the necessary input to the macro, and in the main program, you connect the network variable value to this input, which will then enter the macro. If any of the listed elements fall into the selected area when creating the macro, they will remain on the workspace, but connections to this block will extend to the macro. Data will be transmitted into the macro, and accordingly, will come out to your block. So, connections will still work. Another interesting case is when both the input and output block of the same variable fall into the selected area when creating the macro. If this variable is used elsewhere on the canvas, then only the output variable block will remain on the canvas. The input and output variable blocks will be copied inside the macro. By default, information from the input is not connected to it, so you need to keep this in mind. If you want to write something into these variables from the macro input, you will need to manually draw this connection. If you want to pack a functional block for which there is the write to FB block somewhere on the canvas inside the macro, this element will also be included inside the macro along with the functional block. A separate input will be created to transfer the value to this recording block. By the way, there is a very convenient way to set functional block settings nested inside the macro. Select the functional block inside the macro, find the Use in Macro point, and change its value to Yes. This allows you to edit the list of variables that will be available in the main program. For example, for the TP timer, you can select time unit and impulse length. You can rename these variables, such as time unit TP1 and impulse length TP1, for cases where you have multiple instances. Or you can name these parameters according to the process they control, such as heating set point or lamp duration. Save this macro and see how it looks in the main program. On the canvas, it needs to be updated, as indicated by ALP. Now, when selecting this macro, you can find the variables we configured inside it: time unit TP1 and impulse length TP1. Similarly, you can influence internal variables. For example, inside the macro, you have an integer variable, var1, which passes values to the TP1 timer's impulse length using a recording block. This timer is not used in the macro itself, so its parameters are not accessible from outside. But you can access this variable from outside the macro by setting Use in Macro to Yes. It also needs a name, so let's name it impulse length. To stop ALP from showing an error message, make this variable non-volatile, or record its value into itself. Save this macro, return to the main scheme, and update the macro. Now the impulse length parameter appears in the properties. Thus, you can set up access to internal macro variables from the canvas and manage them somehow. The only thing to remember is that the recording block for functional blocks does not work for macros you create. It only works with standard elements from the component library. You cannot record anything into your macro using it. So if you want to create parameters similar to those in standard components like timers and counters, which users manage when pulling macros onto the scheme, you can do this through the variable visibility inside the macro parameter. But if you want to dynamically change the parameter value inside the macro, depending on the screen input or computations during the program's execution, it is better to introduce such a value into the macro through an additional input. By the way, you can save a macro not only with the Save Workspace icon but also with Save Macro As. When saving, you can give it a new name, like macro2. In the main scheme editor, you will then have two macros in the project, macro1, the version before changes, and macro2, the one saved with a new name. This is convenient when you want to experiment with changes while keeping a backup, previous version, or when you need a similar macro with a slight difference. For example, if you have a group of pumps, and one works slightly differently from the others. In the last video, we mentioned a parameter in the macro editor called group. Let's write something here, like group1, and save this macro. Now, if we go to the main scheme and select our macros in the component library, switching to folder view, we see several groups. Group 1 refers to the edited macro, where we set this group, and group other for macros without assigned groups. This way you can group them into folders, which is handy when working with many macros and needing to organize them. On the workspace, you can quickly replace one macro with another using the replace function. If I use macro 1 but want to use macro 2 instead, I select it from the list, click OK, and the element is replaced. Since both macros have the same input and output names and data types, connections remain intact. Suppose our macro has several inputs, and in the main scheme it looks like this. The first input is called I1, the second I3. If during programming we realize this order is inconvenient because connections cross over, there is a synchronize I/O order function inside the macro. Enabling this allows rearranging inputs inside the macro. Save the macro, return to the main scheme, and update it. The inputs swap places, but connections remain, because their names and data types didn't change. This works for both inputs and outputs. If you want to break this synchronization, making the input-output order in the main scheme independent of the macro's internal order, disable this function inside the macro. Now, rearranging elements inside the macro won't affect the macro's appearance in the main scheme. This way, you can reorder macro inputs and outputs for convenient signal connections on the main scheme, then disable synchronization and arrange inputs-outputs neatly inside the macro. And one last detail. Don't forget about our component manager. It contains many macros created by our engineers. Take a look, your problem might already have a solution there. In the next video, by the way, we will work with some analog conversion elements from the component manager. So don't forget to subscribe, comment, and like the video. See you again soon.